All right, it is Algebra 2 time again, and we are at 7-7. Products of sums containing radicals. Page 265 or page 271, depending on your textbook. 7-7 begins at the bottom of that page. And let me bring my digital textbook over, and let's just start reading, as we've been doing for several lessons now, and see what we read here. In working with products of sums whose terms involve radicals, you usually express results in simple form. Usually. Maybe most often. All right, so here we have the quantity 2 minus square root of 3 times the quantity square root 6 minus square root 2. All right, so what's going to happen here? Well, notice that they treated this like binomials, right? This first term right here, 2 times square root 6, is the first times the first, right? Now this minus 2 square root 2 is the first times the last, right? So this minus sign comes with it. This 2 over here is positive, so this is a positive times a negative, so it turns out negative 2 square root 2. Okay, now what about this third term, this minus square root 18? Well, we have a minus square root 3, or we could say a negative square root 3, and a positive square root 6. So we multiply those, and we're able to multiply the 6 and the 3 because they're each under a radical sign, right? So minus square root 18 then. Now the plus square root 6, we take the negative square root 3 and multiply it to the negative square root 2, same idea. The numbers are both under the radical sign. It's a negative times a negative, so it becomes positive square root 6. Okay, 2 square root 6. There's nothing we can do. 6 is 2 times 3. There's no way to square root that rationally, I guess we would say. Minus 2 square root 2. Nothing to do there. But now this minus square root 18 becomes minus 3 square root 2, right? So think about that. What that's saying, if you think about the factorization of 18, 2 times 9 is 2 times 3 times 3. Well, there's a pair. Well, that's what we need because our index is 2. So the pair, 3 times 3, that pair of factors becomes then the 1, 3 that we bring out because the square root of 3 times 3 is 3. And then square root 6, nothing we can do, right? But now we have like terms, right? If x is equals square root 6 and y equals square root 2, we have 2x minus 2y minus 3y plus x, right? And so that'd be 3x, or since x is square root 6, 3 square root 6 minus, here's a negative 2 and a negative 3, so minus 5y, and if y is square root 2, then minus 5 square root 2, and that's the best we can do. Okay? So hopefully that makes sense, right? And so we started with something that looked a little bit different to us, but it was really nothing more than 2 binomials we could think of it. It's, I don't know that it's, yeah, it's a 2-term thing, right? So, you know, we treated like 2 binomials like we've done before, and we multiplied the terms accordingly, and came to a simple form expression. Okay, top of the next page, maybe 266, maybe 272, depending on which textbook you have. Okay, so here it says rationalize the denominator of 3 over 2 times square root 7 minus square root 10. Rationalize. That means to remove radicals from the basement, okay? So generally speaking, we don't like radicals, and we particularly don't like radicals in the basement, okay? Well, notice the solution. Use the fact that the quantity a plus b times the quantity a minus b equals a squared minus b squared. Okay, well, how is that helpful? Well, if it equals a squared minus b squared, and we're talking about square roots down here, I can remove the radicals, right? Notice what they did. They took the given denominator and they repeated it, but they changed that sign, right? Why did they change the sign? So that they would get a result that's in the form of a squared minus b squared. Okay? Well, how did they get that? Well, look at what happens here. When I take 2 square root 7 times 2 square root 7, 2 times 2 is 4. The square root of 7 times the square root of 7 is simply 7, right? The square root of 7 times 7 is 7. So 4 times 7 gives me the 28. Now when I take negative square root 10 times positive square root 10, I get negative square root 10 times 10. Well, the square root of 10 times 10 is just 10. And so I have negative 10. Now, why don't I get all those other terms? Well, notice that when these two are multiplied right here, right, notice the terms, a square root 10 and a 2 square root 7, it will be negative, because the negative times a positive. When these two are multiplied right here, notice it's the same value terms, or absolute value terms, 2 square root 7, square root 10, but they're going to be positive because both of these terms are positive. So you'll have a negative with these two factors. You have a positive with those same two factors, so they will cancel. That's how we end up with 28 minus 10, which becomes 18 here. Well, we need to multiply the upstairs by that, right? So we just write it as this multiplication. Notice the 2 square root 7 plus square root 10 is put in parentheses because the 3 needs to be multiplied by that entire number, 2 square root 7 plus square root 10. It's not just 3 times the 2 square root 7, it's 3 times the entire number that's represented by 2 square root 7 plus square root 10. Now you might think, well, why didn't they go ahead and multiply that out? Well, with wisdom, we held off doing that to see if we could factor, and we can, right? 18 is really 3 times 6, and so we can factor the 3's. They reduce to 1. And so since we're multiplying 2 square root 7 plus square root 10 now by 1, it's just 2 square root 7 plus square root 10. And that's over 6 because that's what remains after we factor and reduce the 3, cancel the 3's to 1. Okay? So that's rationalizing the denominator. Then it says here, using radicals, you can factor certain quadratic polynomials which are irreducible over the set of polynomials with integral coefficients. What? Let me read that again. That's like, I just said a bunch of words that I'm using radicals. Okay, so we know what radicals are, right? That includes a radical sign. You can factor certain quadratic polynomials, right? So certain quadratic polynomials. That's a second degree multiple term expression, which are irreducible over the set of polynomials with integral coefficients. So if we try to keep everything integers, there are certain quadratic polynomials that we just can't reduce if we try to keep all the coefficients as integers. Okay, so let's see what was done here. X squared minus 8 equals x squared minus the square root of 8 squared. Okay, now, how can we do that? Well, let's stop and think for a moment. I think we're making use of our difference of squares. Okay? You know, if you have x squared minus y squared, that equals what? X plus y times x minus y. Or, as said earlier on that same page that we're on, looking at example 3, at the beginning of the solution to example 2, they said if you have a plus b times a minus b, it equals a squared minus b squared, right? So now we're going to work this direction. We have x squared minus 8, right? Well, if we want it to look more like this form right here, we want a squared exponent on this second term. How can we do that? Well, if you square the square root of a number, you get the number, right? So x squared minus the square root of 8 squared. So here I'm using a radical so that I'm able to factor this otherwise irreducible polynomial, right? And this is true. The square root of 8 squared is 8, so we're true. But this is now the form a squared minus b squared, right? And so that equals what? A, or in this case x, plus b, the square root of 8, times a, in this case x, minus b, the square root of 8. Well, the square root of 8, remember 8 is 4 times 2, or 2 times, okay, I don't know what that little line was there. 2 times 2 times 2, right? So there's a pair of 2's, so that means I can bring a 2 out from under. So this becomes x plus 2 square root 2. And this becomes x minus 2 square root 2. And there's my simplified form. Okay? So if I'm trying to factor a polynomial and it seems to not be irreducible, I mean, it seems to be irreducible, it seems to be not reducible, then perhaps the use of the radical can give me a way to factor it and simplify it. Okay? All right, so this is 7-7, and I'm going to ask you to do numbers 2 through 22 even. Okay? And you're just given a variety of expressions, and you're going to be asked to express them in simple form. And it should be the case that one of the 3 examples in that section will help to guide you through through those problems. All right, now let's go back to our Symbolab calculator and see if this can be helpful to us. So, and again, this is for the purpose of what? Practice, getting fuller explanations, seeing the steps if you have a paid version of it, or seeing what steps you can see in the free version, so that it can help you understand what's going on, right? So let's just take problem number 1, and 5 square root 10, and we'll click outside of that, and let's see, it's parentheses. I guess I'll just use my keyboard and do a parenthesis. Notice how it gives me a set there that I can fill in. And so what I want is 3, and we want square root 2. And I'll just use my arrow key to get out of that box. And we want to say, I think I'm out of that box. Yeah, now I'm out of the parentheses. Okay, I'm out of the box. I'm inside the parentheses. Minus, and then we want to do square root 5. And that's it. Okay, and let's see what happens. We go, and it gives me this solution right here. 30 square root 5 minus 25 square root 2. Let me go to the answer key. Hey, that is the correct answer. Okay, so there I've got the correct answer. You know, if I was unsure of how to do this, I can see the steps here of how it was done, so I can understand how it got to that answer. If I click there, yeah, so it's going to give me Of course, I've got the version that gives all the steps. Right, so I can see all the steps of how it got to its final answer. Okay, so that's pretty cool. Let's try this on maybe something a little more complicated. Let's try this on number 7. Okay, it looks complicated. So we want parentheses. So I'll type parentheses on my keyboard. And then we want a fraction. So I'm going to do that to get a fraction. Now the numerator, I clicked oh, you didn't see what I clicked. Let me get down here. I clicked this guy right here to set up a fraction. Okay, so the numerator wants to be 1. I can type that in, plus, type that in, square root 3. So we'll get the square root guy there, 3. And now I'll click down here in the denominator, which wants to just be 2. I'm going to click outside the parentheses, and if I click this x squared, it should just give me a squared. Yeah. Okay. And so what happens here? It gives me this solution right here, 2 plus square root 3 over 2. I wonder if that's the correct answer. Hey, it is. All right. And I don't know. Okay, there's my steps. They went away for a moment. All right, so then I can see the steps. All right, so the symbollab.com is really helpful, but it's helpful when it's used the way that I'm describing it, as something to use to check your work. You know, maybe you get an answer, and you know, if you're careful about writing out your steps, you get an answer. You check it, and you can follow your steps with these steps, and you can see where you made a mistake, and so that can be helpful. Okay. All right. So again, your assignment numbers 2 through 22 even. This is 7-7, page 272 or page 266, depending on which textbook you have. Enjoy assignment 7-7.